Welcome back to the deep dive. Today, you've handed us a stack of sources detailing a really ambitious open source project. And our job is to distill what's making everyone pay attention.
We are diving deep into MiroThinker. And this isn't just, another model being dropped online. It's an entire integrated system, a full blueprint built for what they call tool-augmented reasoning.
Real-world information seeking.
Exactly. Think of it as an open source attempt to build the perfect digital research assistant for everyone.
And the project's mission seems crystal clear. They are explicitly aiming to match the deep research capabilities of the big commercial models like OpenAI Deep Research or Gemini Deep Research. They're not just trying to compete, they want to set a new standard.
Which brings us to the big question we need to answer for you today. How is an open source model doing this? I mean, conventional wisdom says you need billions of dollars in closed proprietary data to get world-leading performance in this kind of complex research.
So what's the secret?
It turns out they didn't just build a better model. It seems they built a better factory.
Okay, I like that analogy, a better factory. Let's unpack that, because we usually just focus on the final product, right, the model itself. But your sources say the secret is in the whole system.
Yeah, the whole structure, it's built on these 4 pillars. And what's really crucial to understand is that for this kind of research to be reproducible, especially for the open source community, you can't just release the model weights.
You need the whole ecosystem.
You need the whole ecosystem.
Yeah.
And that modularity is exactly what the MiroMind project provides.
All right, lay out the 4 pillars for us. Let's start with the finished product, the model.
So pillar number 1 is MiroThinker. That's the core model, the open source search agent itself. And it's not some general chatbot they retrofitted with tools. It was designed from the ground up to do tool-assisted reasoning.
And the latest one is V1.5.
That's the one, yeah.
Yeah.
The one that's really pushing the boundaries.
So that's the brain. But what about the instructions, the system it follows to actually act like a researcher?
That's pillar 2, MiroFlow. And this is the open source research agent framework. So if MiroThinker is the car, MiroFlow is sort of the standardized road and traffic system it drives on.
Okay, so it provides consistency.
Exactly. It ensures the model can be deployed again and again, and you get reproducible state-of-the-art results on all these different benchmarks. Without the framework, the model is just raw horsepower. MiroFlow gives it strategy.
And we all know the old saying, garbage in, garbage out. A model is only as good as its training data. So pillar 3 must be the data.
And this is a huge differentiator for them. It's called MiroVerse. This is their own premium open source training data set. We're talking about 147,000 samples.
147,000, that actually doesn't sound like a massive number compared to what we hear about for general LLMs.
It's not, but that's the point. These aren't just random snippets of text from the internet. They are specifically engineered to train a research agent. They show the model how to do complex multi-step thinking, how to use tools, how to correct its own errors.
So it's not learning to write a poem, it's learning how to write a methodology section for a research paper.
That is the perfect way to put it. It's the difference between a general education and a PhD program. And the quality of that data, MiroVerse, is what lets the agent go beyond just answering simple questions.
So we have the model, MiroThinker, the system, MiroFlow, and the specialized curriculum, MiroVerse. What's the last piece? What holds it all together?
That's the final pillar. MiroTrain, MiroRL. This is their training infrastructure. Because they're focusing so heavily on this idea of tool interaction and feedback, which we'll get into, they needed a stable, efficient way to train these specific kinds of agent models.
So by releasing the whole stack, the data, the framework, the infrastructure, they're not just giving away a model.
No, they've effectively democratized the methodology for building world-class research agents.
And that integrated ecosystem is what enables their big idea, this concept they call the third dimension of scaling. This is where it gets really interesting for me because it kind of changes how we think about AI progress.
Right. I mean, traditionally, when we talk about making an LLM better, we talk about 2 things. First, model size, add more parameters, make the brain bigger.
And second, context length. Give it a longer memory.
Bigger brain, longer memory. That's been the roadmap for years. But MiroThinker introduces this third dimension. Interactive scaling.
Okay, interactive scaling. So it's not about size or passive memory.
No, it's about the quality and the depth of its engagement with the outside world. They systematically train the model to handle deeper and much more frequent interactions with its environment, with its tools.
So instead of just thinking internally, it's constantly pressure testing its ideas. It uses a tool, looks at the feedback, sees if it failed, and then corrects its course mid-task. It's like turning a monologue into an active dialogue with the world.
That's it. The training is all about leveraging that external feedback. If a search result is junk, it learns to try a different query. If its code breaks, it learns to debug it. That's what lets it tackle these huge tasks that require hundreds of steps.
And the numbers for V1.5 really put that depth into perspective. The context window is huge.
It's massive. The V1.5 model supports a 256K context window. That means it can hold the prompt, its own reasoning, search results, code logs, everything all at once while it plans the next step.
And the number of tool calls is just staggering.
It is. The first version, V1.0, could do up to 600 tool calls, which was already nuts for open source. The V1.5 version handles up to 400 tool calls per task. I mean, just think about that. Most early agents would get lost after maybe 10 interactions.
What really stands out here is the efficiency gain. We always assume the biggest models just automatically win, but focusing on interactive scaling seems to change that.
This is the real surprise in the project. They have this great example comparing their smaller model to a commercial rival. So MiroThinker V1.530W, which is a pretty small model by today's standards, it actually surpasses Kimi K2 thinking on a tough Chinese web browsing benchmark.
Impressive. But what's the kicker?
The kicker is that the 30B MiroThinker does this using only 1/30th of the parameters of its competitor.
1/30th.
Yeah. We are talking orders of magnitude cheaper to run, to train, to deploy.
So that completely flips the script. It suggests that high-quality, specialized data and this deep interaction training are way more important for research tasks than just making the model bigger and bigger.
Absolutely. And the fact that they release it in different sizes like 30B and 235B means a small team or a researcher can actually run the high-performing 30B version on their own instead of being locked out by the costs of these giant models. That might be the biggest practical implication of this whole thing.
Okay, so let's talk validation. If they're claiming world-leading performance, we have to look at the benchmarks. Where is MiroThinker actually setting new records?
It's setting them across the hardest agent benchmarks out there. These aren't, simple trivia quizzes. They require real planning.
Give us the numbers, but more importantly, what do they mean?
All right, so looking at the biggest model, the V1.5235B, it gets 39.2% on HLE text, which is a subset of the humanities last exam benchmark. It scores almost 70% on BrowseComp and over 71% on the Chinese version.
But the big one is GAIA.
The big one is GAIA. It scores 80.8% on GAIA Val 165. That's the General AI Assistance Validation Set.
So why are benchmarks like GAIA and HLE considered the ultimate test? What makes those scores so hard to get?
That's a great question, because they're not just about finding one fact. GAIA might ask a question that requires you to, say, search for two conflicting sources, synthesize them, then run a Python script to calculate something, and then use that result to do another search. They test reasoning over a long chain of actions.
So hitting 80% on GAIA means it's not just a fancy search engine. It's a critical thinker that can use tools and refine its plan. That's a huge step.
It's a massive step. The earlier V1.0 release was already getting close to closed systems like GPT-5 High, but these new V1.5 scores really show that interactive scaling is what pushed open source over the top.
Now, to do all this, the model needs its tools. It can't browse the web or run code by itself. So what's the essential tool stack you need to make MiroThinker work?
The team defined a minimal configuration that relies on 3 external tools. And this is where they're really transparent, which is great for anyone trying to replicate their work.
Okay, lay it out for us.
First, you need ToolPython. That's for running code and managing files. They use the E2B sandbox for that. Second, you need Search. That's Search and Scrape Web Page, which uses the SERPer API to get real Google results.
And the third one sounds a bit more complex.
It is, and it's really clever. It's Jina Scripelm Summary. So it uses Jina.ai to scrape web pages. But here's the trick. It has a smaller secondary LLM, like a Qwen 314B or GPT-5 Nano, built right in to summarize the scraped content on the fly.
Wait, hold on a second. Let me get this straight. You're telling me that the web scraping tool has another smaller LLM inside it just to clean up and summarize the data before passing it back to the main MiroThinker agent.
That's it, exactly. It's a really smart division of labor. Instead of giving the main agent a whole messy web page full of ads and boilerplate, the little summary LLM filters out all the noise first.
So MiroThinker only gets the good stuff, the high-quality information.
Right, which makes its own reasoning process much more efficient.
But this does bring up a challenge I have with the open source label. If the core setup requires commercial API keys for SERPer, Jina, E2B, is this truly an open source capability for the average person? Or is it an open source model that relies on a paid closed infrastructure to actually do its job?
That's a really powerful and fair distinction. And it does reflect the reality of where we are with agent development right now.
Mhm.
The open source parts are the brain MiroThinker, the framework MiroFlow, and the training data, MiroVerse. You get the whole recipe.
But you still have to pay for the ingredients, the connections to the live internet.
Exactly. You get the brain for free, but you still have to pay for the high-speed connection to the world. And they're also transparent that for tasks involving images or audio, they have to use something like GPT-4o to pre-process those files into text first, because MiroThinker is text only.
Okay, let's pivot back to that high volume of interaction. We said it can do hundreds of steps. That must create a huge technical problem with context bloat, right?
It's the classic failure mode for the standard React agent design. In React, every single thing, every thought, every action, every tool output just stays in the context history forever.
So by tool call 300, the model is just drowning in old, irrelevant information.
Drowning is the right word. It can't focus. It's like a researcher whose desk is piled high with every single piece of paper they've ever looked at. Eventually, they just lose track of the actual goal.
A very cluttered desk. So how does MiroThinker solve this? How do they clean the desk?
They developed this really elegant solution they call recency-based context retention.
And how does that work in practice?
So they have this setting, keep tool results, and it basically tells the agent to only keep the most recent tool responses in its memory. And for most setups, they recommend K equals 5.
So wait, it throws away the actual results, the observations from older steps?
It throws away the old observations, yes. But, and this is the key, it keeps the complete history of its own thoughts and actions. It still knows why it did something 100 steps ago. It just doesn't keep the messy web page it got back then.
So it preserves the reasoning trace, the blueprint of its plan, but aggressively prunes the old evidence.
Precisely. And by doing that, they get like 4 huge benefits. First, it focuses the model's attention on what's most relevant right now.
Which is critical for planning the next step.
Absolutely. Second, it frees up a ton of context space. That's how they can sustain those super long, deep research projects without running out of memory.
And the other benefits are about performance.
Right. It's faster and more efficient because it's not wasting time processing old data. And fourth, and this is the most amazing part, they found it does not hurt performance. If anything, by forcing the agent to focus, it often makes it better.
That's fascinating. It proves that the intelligence isn't just about how much you can remember, but how intelligently you manage what you remember. Sometimes, less context is more effective context.
It allows the model to use its mental energy where it matters most, on the present moment and the next 100 steps.
This has been just a fascinating deep dive. If we were to summarize the main achievement of MiroThinker, it seems to be this. It demonstrates that by focusing on interactive scaling, the depth and frequency of tool-use open-source agents can actually achieve performance parity with, and maybe even superiority in efficiency over the big, closed commercial models.
And we have to say it again, the whole recipe is open. The MiroThinker model, the MiroFlow framework, the MiroVerse data, it's all MIT licensed. They didn't just give us a powerful tool, they gave the whole community a blueprint to build their own.
Which completely changes the game for knowledge acquisition. If these highly capable, context-managed agents become the standard, accessible research method for everyone, the speed of discovery in basically every field could accelerate dramatically.
And that really raises a provocative thought for you, the listener, to take away from this. Given the capability and the efficiency we've just talked about, and knowing this potential for deep automated research is now out there, what specific complex area are you most curious to unleash a research agent on? What knowledge is currently locked away that this technology is finally starting to open up?